Hello, we are in Chapter 6, Section 6.4, Equations Quadratic in Form. In this video, we are going to go over the idea of equations quadratic form and U substitution. Let's start with reviewing solving a quadratic equation. We will solve the one that is given in here. We notice that it is factorable, and we know that factoring is the best method of solving quadratic equations. And it factors as x minus 3, x minus 4 equals 0. So using the zero factor property, we get x minus 3 equals 0 or x minus 4 equals 0, resulting in x equals 3 after adding 3 to both sides of the first equation, or x equals 4 after adding 4 to both sides of the second equation. And those are the two solutions to that equation. Let's ask a question now. How are the equations x to the 4th minus 7x squared plus 12 equals 0 and the equation that we just solved similar, and how are they different? Well, notice that coefficients are the same. We have 1 here, we have 1 there. We have negative 7 here, we have negative 7 there. We have 12 here, we have 12 there. It's just the powers on x differ between the equations. We have x to the 4th here, while we have x squared there, and we have x squared here, while we have just x in there. So this 4th degree equation looks almost like our quadratic equation that we started with. It's just, it's not x that is in the first and in the second power, but it appears there is something else that is in the first and second power, because the difference between x squared and x to the 4th is exactly 2 as a multiple in the exponent. So the question is, how can we rewrite the first term of that new equation, which is x to the 4th, so that it is written with an x squared in it? So we can use this as the building block, pretty much. Well, 4 is twice 2. So if we write it using exponential notation as x squared, then it is x to the 4th, because when we raise an exponential to a power, then we keep the base the same and multiply the exponents. So that tells us that in the new equation, what is in the first and then second power is actually that x squared that we have in here. So we are going to substitute something else for that x squared in that new equation, and it will become then a quadratic equation. So we're going to substitute u for x squared in that equation. So every occurrence of x squared in here will be replaced by u. So we're going to have u squared minus 7u plus 12 equals 0. So now we can solve that equation for u. We notice that this is pretty much the same equation that we started with, just instead of x we have u, so it's going to have the same solutions as our original equation, but in terms of u. So it will be u equals 3 or u equals 4. Now, notice that what we started with, the 4th degree equation, had x in it, and we then substituted u in, so that we obtained the quadratic equation in u. Now we got the u solutions. How I think about it is like translating between languages. The original equation in the language of x has been translated in the language of u using the dictionary that we have in here. Every x squared has been translated to u. Now, we solve that new u equation in the language of u because we understand the language of u much better. It's a quadratic equation in the language of u that we know how to solve. And we obtain those solutions in the language of u. But we need to translate back into the language of x to get the solutions in terms of the original variable, in terms of the original language of that new fourth degree equation that we are trying to solve. So now, every occurrence of u will be replaced back with that x squared. So we're using our dictionary kind of the other way around from the u language to the x language to rewrite those two equations stating the u solutions in the x language. So we're going to have x squared equals 3 or x squared equals 4. And now we solve those two equations that are now easy equations to solve for x in the language of x, and we will get the solutions to that original fourth degree equation. We are using the square root principle in both of them. In the first one, if x squared is equal to 3, then x itself is plus or minus the square root of 3, and we can't simplify that any further. And in the second one, if x squared equals 4, then x itself equals plus or minus the square root of 4, which is simply plus or minus 2. So there are 4 solutions altogether in here. Positive square root of 3, negative square root of 3, positive 2, and negative 2 to that original equation. Always or between. Just to make sure, let's quickly check our solutions in that original fourth degree equation. Notice that when plugging in for x, it is squared and raised to the power of 4, and squaring or raising to any even power will always make numbers non-negative. Therefore, plugging in positive or negative square root of 3 or plugging in positive or negative 2 will result in the same thing. So it's enough to do 2 checks in here. So starting with positive or negative square root of 3, we're going to have positive or negative square root of 3 raised to the power of 4 minus 7 times, again, positive or negative square root of 3 raised to the power of 2 plus 12. That's the left-hand side. As always, we are checking if it equals to the right-hand side, which is 0. So let's simplify what we have in here. Square root of 3 raised to the power of 2 results in 3 already, and that 3 then needs to be further raised to the power of 2 to give us square root of 3 to the power of 4 altogether. And 3 squared is 9. Then, as I already said, square root of 3 squared is just 3, so we'll have minus 7 times 3, and then we have plus 12. Now, 7 times 3 is 21, 9 minus 21 is negative 12, and negative 12 plus 12 is indeed equal to 0, the right-hand side. So, plus or minus the square root of 3 is indeed a solution to our original fourth degree polynomial equation. And then, for x equals plus or minus 2, we proceed similarly. Plus or minus 2 to the power of 4 minus 7 times plus or minus 2 to the power of 2 plus 12. Again, 2 to the 4th is 16, and as we already said, the even exponent takes care of the signs, making the numbers non-negative, so we're going to have just 16. Then 2 squared is 4, so we have minus 7 times 4, and then plus 12. 16 minus 28, because 7 times 4 is 28, is negative 12, and negative 12 plus 12 is, well, 0, which is the right-hand side, meaning, again, that our numbers really are solutions to that fourth-degree polynomial equation. So all 4, positive and negative square root of 3 and positive and negative 2 are solutions to that fourth degree equation. And this method of U substitution can be used whenever our equation looks like a quadratic equation, but with a different building block, with a different variable we can see, with a different expression that is once in the first power and once in the second power in that equation. And U will be substituted in for that building block to then solve in the language of U, and not to forget to translate back in the language of the original variable, whatever it is, like x in this example.